Okay, so so the square root of 10 over the square root of, wait, the square root of 10, oops, the square root of 10 over 9 is the exact same thing as the square root of 10 over the square root of 9. Yeah, so a lot of times when you have a fraction under a root, you want to split it up into two. And a lot of times when you have them split up into two, you want to put them into one. So if you have this, so this becomes the square root of 10 over 3. Now, a harder problem would be the square root of, let's say, 9 over 13. Okay, so that's a harder problem. So what you want to do is you want to split it up like normal. And then you're like, oh yeah, cool, I can take the square root of the top number, which is 3. But you're not allowed to leave a root in the denominator. So what you do, and this is similar to imaginary numbers, is you want to multiply top and bottom by what's downstairs, which is the square root of 13. So remember, when you multiply top and bottom by the same number, what are you really multiplying it by? No, like what is this number? What is this? No, that's 1. That's just the number 1. Like what is 5 over 5? That's 1, right? Anything over itself is just 1. So you're not changing the value of this guy. You're just putting it in a more like math grammatically correct way. So along the top, what are you going to get? And on the bottom, what are you going to get? No. Dueling, this is dueling fractions. Yes, but do you know the happy face rule? The happy face rule is the square root of happy face times the square root of happy face is just happy face. So on the bottom, what is it? 13, because it's really the square root of 169, and then you gotta punch out 169 in the calculator, the square root, and you're like, oh, well, that's just 13. So it's, and you're just going across the bottom because it's multiplication. So, and the whole point of what we just did is called rationalizing the denominator. The whole point was to get the root out of the denominator. You're not supposed to have a root downstairs. So that's it. What's that? Yeah, these guys cannot talk to each other. Well, because one is in the root and one's out of the root. If this was like a 39 right here, I'll try to squeeze a 9 right there. So if that's a 39, right? Yeah, because you could say 13 goes into itself once, 13 goes into 39 3 times. The answer is really 3 root 13 over 1, but you don't need the over 1. It's just 3 root 13. You can't. There's nothing, you can't factor tree 13. 13 is prime. Yeah. So yeah, you want to keep going. So if you were at this step and you had like more work to do like that, then you could factor tree 18. Another way of doing it without doing the factor tree takes a little bit more thinking, but you can go, all right, let's chop up that number 18 into what I know for sure has a perfect root. So I know 9 has a perfect root, and that's times 2. So that's really 3 times root 9 times root 2. And then it was just then 3's out, and then you have 3 times 3 times root 2, which is 9 root 2. And we're just to give you a quick preview. Um, so like, well, real quick, like what if you have like 2 over root 7? How do you deal with that? Yep, you multiply top and bottom by root 7. And what do you get in the bottom, which is the whole point of doing all of this? 7, and on the top? Okay, and that's it. Now, the other thing you have to know how to do, and this also applies to imaginary numbers, is if you have something like 3 over 3 minus root 7, and I'm going to use a different number than 3. See that? Okay, so what you want to do with this is done very, 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 very differently than what we just did here. In fact, a rookie move would be to do what? Yes, if your rookie move would be this, and that would be a no-no. So instead what you want to do is almost like the rookie move, except you want the opposite sign in the middle. And this is called the conjugate. So 2 plus root 7 is the conjugate of 2 minus root 7. And the reason you want to do that is because if you multiply a number by its conjugate, you're going to get a middle wipeout. So for example, if I do x plus 3 times, I'm going to use a different number, x plus 6 times x minus 6, those are conjugates. Why are they conjugates? Oops, not 6. Why are those conjugates? Signs are different. All right, so let's FOIL it open. What do you get for your first? What do you get for your last? Sorry, what do you get for your outside? Outside. What do you get for your inside? What do you get for your last? And yeah, it is negative 36. Okay, and then yes, you're always, when you multiply by conjugates, you're always going to get a middle wipeout every single time. So actually, normally when we do these problems, we think of FOIL. That's a F. We think of FOIL. But when you're dealing with conjugates, you actually don't need to deal with the outside and inside at all. So you just need to multiply your first and last, because the middle will swipe out. Okay? So let's go ahead and just so you can see it happen. Let's go ahead and FOIL what's in parentheses for the roots right here. So what's our first? No, what's our first? 4. What's our outside? 2 root 7. Yeah. So plus 2 root 7. What's our inside? Do you see our wipeout happening right there? And then what's our last? Positive or negative? You have a negative times a positive. So it's a negative. So your negative root, negative 7. Huh? So it would be minus. Okay, so this is, if you didn't do if you kind of worked out the last step a little bit more, what you're doing is you're doing negative root 7 times positive root 7. Now and you have an invisible one right here, and you have an invisible one right here. So negative invisible 1 times positive invisible 1 is negative invisible 1, and then you have the square root of 49. And the square root of 49 is 7. So that gives you negative 1 times 7, which is negative 7. All right, so you get your middle wipeout right there. You see that? So now that you know that, you never have to actually FOIL it open. You just do your first and your last when you go downstairs. So down here, what's your first? Minus, and then happy face rule. Yeah, minus 7. And then what do you get? What do you get on the top? Good. Yeah, so on the top, you kind of think of that as like that. You want to distribute. So you have 6 plus 3 root 7. So that's 6 plus 3 root 7 over negative 3. And that's a weird way to see it. Like textbooks don't like to present their answers like that. So what you want to do instead is you can kind of think of it as like, all right, I'm going to move that. Oh yeah, you could definitely do that. Well, let's handle that in a second. So let's just deal with the negative sign. So textbooks don't like the negative on the bottom. Okay, so what they'll do is they'll say like, all right, well, let's just multiply top here. I'm just right over here. 6 plus 3 root 7 over negative 3. You can think of it like this, like let's just multiply top and bottom by negative 1. All right, if we multiply top and bottom by negative 1, what do we get in the bottom? What do we get on top? negative 6 minus 3 root 7. Uh-huh. When you do, what do you mean? Oh, yeah, you do. It's if you have negative 2 minus root 7, and then the conjugate would be negative 2 plus root 7. Okay. Um, so you're right though about the simplifying thing. So how would you reduce this? So you would, if there's two ways to do it, you could, one that's problematic sometimes is this way. You go, all right, 3 goes into itself once, 3 goes into 6 two times, 3 goes into 3 one time. That's one way to do it, but you have to be very comfortable with that. The other way of doing it, which is a little safer, is 6. So you're splitting your fraction. So that's negative 6 over 3 minus 3 root 7 over 3. And this 3 is the same as this 3 and the same as this 3. You split your fraction. Now you can just reduce it like normal. All right, so 3 goes into itself once, 3 goes into 6 two times, 3 goes, and these guys wipe each other out, and you end up with 1s down below. So if you wanted to, you could put it back together again. You can get negative 2 minus the square root of 7, right? Negative 2 minus, that's gone. There you go. What if, back up, what if what? Okay, okay, great. So it's a good question. Like that, right? Well, this goes like that, and this goes like that. But I think I know what you're kind of getting at. It's, yeah, becomes some, yeah, you're talking about what if you have, and that's why the first method is problematic, is, hold on, is if you have something like, well, let's put like a 13 right here, like that. Okay, so this either has to stay put, like that's done, or you can split your fraction, and you get negative 6 over 3 minus 13 root 7 over 3, and then you say, all right, well, 3 goes into itself once, 3 goes into 6 two times, that's negative 2 over 1, which I don't really need the over 1, and then minus 13 root 7 over 3. And I cannot combine them. So you either stop it here or you stop it here. But the reason why the whole like wiping at this stage is problematic is I feel like people are going to, I feel like some kids do this and they're good. And that's wrong. You don't do that. You have to do it to all of them. So you have to go, all right, 3 goes to itself once, 3 goes to 6 two times, and 3 goes into this number however many times. And if you cannot do all 3, you can't reduce it unless you split your fraction. So yeah, it's safer to split your fraction. When I was in school, I used to just split my fraction. I would do it this way. But you should be aware of both, because sometimes the answers on the SAT are presented like this. That's considered, that's as far as I can go, and that's as far as this could go. They're both the same thing. Yeah, well, it just has one side simplified a little bit more, but they're both actually correct. You get that? All right, 1 second. Okay, so let's say so looking at this problem here, you have root 10 over, oops, you have root 10 over 9, right? And you want to split it up. So you have root 10 over root 9. All right, so you have root 10, you can't deal with that on top, and over, and what is the square root of 9? 3. And is 3 upstairs or downstairs? Yeah, because this guy, the original one, is downstairs. It's gotta stay, can't float to the top. Gotta stay there. You mean like this? Okay, so if root 9 over 10, it'd be root 9 over root 10, multiply both sides by root 10, and then it'll be root 90 over what? over 10 because of what rule? The happy phase rule. So you have root 90 over 10. And wait, let's bust up 90. What's the square root of 90? Yeah, it's root 9 times root 10, so it's 3 root 10 over 10. Anything else? Can you do anything else from there? No. All right, try the next one. Okay, so you took the square root of 125, right? Well, first of all, we split your fraction, right? So root 125 over root 4. And then what'd you, what'd you get in the bottom? 2. Okay, and then on the top, let's just factor tree the top. Okay, so 5 and 25, and then what? Okay, 5 and 5. 1 goes out of jail. 1 gets killed. 1's out. So this 5 goes out of jail. So this 5, so this one comes out. And what about the other 5? Yeah, that 5 stays in. So that's in. And then we end up with 5 root 5 over 2. Right? And you can always check the top because you just go this 5 times itself times the 5 on the inside. So 5 on the outside times itself times the 5 on the inside should take you back to the original. You took the 5 out, just then do the factor tree. What's that? The, the factor tree is the safe way. I would do the factor tree, I would do the factor tree if I were you. It's safer. Okay, walk me through this problem. Okay, so you split it up, you got root, wait, well technically, if you just split it up, you got root 25 over root 45. 5 over root 45, okay? Okay, okay. So bam, 1 comes out. So the 3 comes out, the 5 is left behind, right? And that's under the root. So then you have 5 over 3 root 5. Okay, now you have to rationalize the denominator, which means you got to get rid of the root downstairs. Good, so you're going to go 5 over 3 root 5, and then times root 5 over root 5, and you're going to end up with 5 times root 5, which on top, which is what? Which is just 5 root 5, right? All right, and on the bottom, in the bottom, you have the happy face rule happening right here. So yeah, it ends up being 3 times 5. And what is 3 times 5? 15. Okay, so you have 15. And then, yeah, and the way I do this, like when I was in school, I was notorious for making this mistake. Like I would present my answer like this. Bam! Do you see my mistake? It doesn't move up. So what really helped me out, and I don't know if I saw a kid do this or a teacher, I don't know, but somewhere along the line, I learned just to say in my head, 5 goes into itself once, 5 goes into 15 3 times. And then you get like the 1's on top and the 3's on the bottom. You'll never make that mistake. So you'll end up with root 5 over 3. Oh yeah, because you just have this 3, you have to make it, you didn't reduce it. You didn't multiply them together. And I don't think you'll ever use star as times either. Oh.